video is to review and introduce acceleration due to gravity. And so one thing we need to know is the definition for free fall and what free fall is. In physics, it's a very, very specific thing. And free fall is when the only forces acting on an object is gravity. It will be accelerating at what we call g. It's important to note, when something's in free fall, we're even considering it not to be encountering air resistance. So oftentimes this is a theoretical thing we think about. It's useful, but air resistance often plays a role, and we assume zero air resistance and conditions of free fall, but it does not actually happen that often, but it's useful as we consider things. Now, if we do look at acceleration being A, we've talked about that as part of, if you remember, we have our very, very annoying to draw, initial, final. Remember that A is acceleration. It's important to note sometimes there's a special condition of A, and it's called G, and this is just acceleration due to gravity. So a second ago, that's when an object is in free fall, it's accelerating at G. G is actually a constant. It's acceleration due to gravity. It's typically valued at negative 9.8 meters per second. Oftentimes, occasionally we'll round it to 10. It's useful in just quick calculations. It is always, always, always downward, and therefore always, always negative. A lot of times this gets messed up because we forget to put that negative in there. How is that relevant? Well, a good example of that would be if something is dropped off of a cliff, say a ball is dropped off of a cliff, we remember that G is approximately negative 10. Well, an example of this would be if the ball is here, as it starts to go down at 0 seconds, it would have a velocity of 0 meters per second. As it goes, as time passes, each second that passes, it would have an additional negative 10 meters per second added to it. So you can see after 4 seconds, it'd be traveling at negative 40 meters per second. If we were going to try to figure out the distance it traveled in that time, we could, of course, run it through our equation that we've had, but you also can always think the average between 0 and 40, halfway, would be 20. And if it's averaging 20 for a total time of 4 seconds, then the distance it traveled in that amount of time would just be 4 times 20. So in this case, it'd be 80 meters. If you don't get that logic, that's okay. You can always use your very, very annoying to draw variables and then use those 4 big equations to calculate that at any time. Another example we would have would be if a ball was getting thrown straight up in the air. This ball goes up in the air and then comes back down. And this is a good reason why we always want to remember negative 10. The ball would be going up, 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 but as each second passes, you'll notice it's subtracting 10 from its velocity. So we have 30, 20, 10, 0. That's because up is the positive direction and it's a negative velocity. But then as it starts to go back down, after one more second, negative 10, negative 20, negative 30. So a total of 6 seconds would pass. So it's effectively got the same speed when it leaves and hits the ground, but they're in different directions. We have different velocities, positive 30, negative 30. The entire time it was on this entire, this would have been in free fall, going up and back down actually would have been in free fall, because if we pretend there was no air resistance, the only force acting on it would have been gravity, and it would have been accelerating downward that entire time. Of ballpark, negative 10, negative 9.81 is the actual published value at sea level. Thank you, best wishes, and I hope this helps.